Welcome to this afternoon session of the first ML Ops Interactive Conference dedicated to understanding of best practice, methodologies, and principles of effective ML. My name is Nadia, and I'm a machine learning engineer at Wave, and I'm honored to be here today and to have the opportunity to introduce some of our amazing speakers. Before starting, I would like to remind you all that if you have a question, please post it in the chat. I will collect all the questions and ask them directly to our speaker on your behalf at the end of the presentation. Our speaker is Luna Feng. Luna is a research engineer at Thomson Reuters Cognitive Computer Center. In this role, she takes initiative to understand various business needs and incorporate AI capabilities to reduce the cost, increase the efficiencies, and improve the bottom line performance. Her current assignment is utilizing the state-of-the-art AI models to solve the real-world problems, especially in the legal domain with natural language processing techniques, such as entity extraction, document classification, information retrieval to provide insight of a document to the legal practitioner to improve their work efficiency. She is passionate about teaching people how to apply AI into practice use, including how to formulate a real-world problem as an AI problem, and how to identify the challenges and overcome them using various techniques. Most recently, she is fine-tuning existing language models toward the legal domain to address the challenge due to the nature of the legal documents. Outside of work, she enjoys traveling with her families and friends and taking pictures of them. Please join me in welcoming Luna Feng.
Thank you, Nadia. Thank you for the very long introduction. Okay, cool. So I'm just maximize my presentation slides. And the first thing, I want to apologize if you feel like I'm not looking at you because I have my presentation material set up on this way. But anyway, good afternoon, everyone. My name is Luna Feng. I'm a research scientist from Thomson Reuters AI for Cognitive and Computing Center. So today I'm going to give a talk with the topic, create harmony between machine learning engineers and the researchers. Though currently I'm a research scientist, but I've been working as a software engineer in our team a few years ago. So I have both experience working as an engineer and a researcher in our team. So I see both roles from different perspectives and how each other is working with their counterpartners in a machine learning project. So in this talk, I'm going to introduce the workflow and the skill set from both of the roles and present some findings and suggestions based on the surveys I conducted within our team a few weeks ago, as well as my own experience. So the motivation of this talk is a successful machine learning product usually involves two important roles that are machine learning engineers and the machine learning researchers. And there is a big difference between the style of work and the background of those two roles. And this is also the reason why the leading technology companies have decided to have separate teams to focus on machine learning algorithms and the machine learning engineering. So that's our team. So as you already may know, machine learning researchers are people who work with data and build machine learning models. They usually clean and interpret data and build models using a combination of machine learning algorithms and data. As for machine learning engineers, they do anything from data lake setup and management to building easy-to-use computational clusters for training, and finally, they need to ensure high availability deployment of those models. The background and the working style of those two roles are different in nature, which brings some challenges to collaborate efficiently with each other. So for example, to build real-world machine learning applications, there are a lot of things to be considered. So for example, the world changes, we usually, as a researcher, we get new data and we need to retrain the models. And also, if a model is going to the production, they have to be tested and monitored. And also, we need to understand the main driver for the product is the long-term ROI instead of just getting the research result. So the software infrastructure supports are required, such as building the data pipelines, automated the testing, auto-scaling the computational clusters, and ensuring the high availability for serving the models. And this all is something most researchers have never done before. And that's why we need the machine learning engineers to support researchers and help them to bring the models into production. And machine learning production is very complicated. In many ways, it's even more complicated than normal web scale systems. So here is an image I get from Google researchers team study that illustrates the complexity and the scope of the surrounding machine learning infrastructure in real world machine learning systems. So as you can see, there are many things to consider, and collaborations between engineers and the researchers is required and is very important. And how to make this whole process of bringing a researcher's code or their model into production more efficiently is the motivation of my today's talk. So to better understand the way our researchers and engineers collaborate, I sent out a survey within our group weeks ago and collected the responses related to being an engineer or researcher and their experience of working with their counterpartners. I got responses from 8 researchers and 8 engineers, including the experience from myself. So I'm going to summarize the responses from the survey, and along the way, you will see how those 2 roles are currently working with each other in our team, and you will get some suggestions as we the suggestions we obtain from each of the roles. So first, let's take a look at the skill set of those 2 roles. For engineers, they usually have skill sets that are Python, Java, Docker version control, system design, API design, DevOps, Lambda function, or step function, and SageMaker in AWS. As for researchers, they are good at using Python, Java, R, version control, SageMaker in AWS, and the machine learning libraries such as scikit-learn, NLTK, Spacy, and the machine learning frameworks such as TensorFlow, Transformers, and PyTorch. So as you can see, the skill set overlaps between those 2 roles is only 24%. And this justifies what I just mentioned earlier. The background between engineers and the researchers is very different. And then let's see what a day looks like being an engineer or a researcher. So for engineers, they usually work on improving the system design and the associated automation. They integrate machine learning models in the REST-based services and creating scalable, extensible machine learning infrastructures on AWS, for example, in our team. And they also fix bugs, develop, integrate, and test new features or models from the researchers. As for researchers, they usually start a day by reading research literatures, pre-processing data, and implementing ideas and running experiments in SageMaker notebook. And also they do error analysis of the results, interact with subject matter experts, fix bugs, and write research papers. So now the question is, what are the usual tasks involved when researchers and engineers collaborate? So the answers I get can be summarized into 5 categories, 5 tasks. So the first one is code walkthrough and review the code. Both engineers and the researchers need to be on the same page with the input and output formats of each component in a product, if necessary. And also researchers need to help engineers to understand and make sense of the model's results. So this helps engineers to test the model once they refactor the code. So this leads to the second task, which is the code refactoring. Engineers need to spend a good amount of time trying to decrease the running time, checking the thread safety, and checking the memory usage. When they refactor the code, they need to check with researchers to make sure those changes won't affect the output from the algorithm. The third task is adding or fixing unit tests. So currently in our team, the unit tests are written by engineers, and the researchers are using it to test their integrated model or code. The fourth task is building, testing, and analyzing the integration of a new feature. And this involves many interactions between engineers and the researchers, because researchers need to make sure the engineers understand the new feature and how the new feature will impact the results and so on. And the last task is fixing bugs. So in our current setup in a product, there is usually 0% collaboration between engineers and the researchers during the research phase, 30 to 80% collaboration during the deployment phase, and less than 10% collaboration at the post-deployment phase. So in terms of whether people find time consuming working with their counterpartners, around 47% responses are on the low scale, that they don't think it's time consuming. And around 53% of team members stand in the middle. So this means we are not doing bad, but there's still room we can improve. So then we asked, what is the skill set? Or maybe the skill set here is not an accurate word, but we try to understand what people think their counterpartners should have that can help to improve the work efficiency. So from researchers' perspective, they think if engineers can communicate about their priorities and the purpose of tickets. So because engineers usually plan their tasks using tickets, and those tickets may associate it with some requirement or some changes from the researchers, but sometimes the communication between or regarding the tickets are not very clear. So what our researchers think is if we can understand the engineers' priorities, it will be easier for them to follow and prepare for what engineers need. And also, researchers think if engineers have technical knowledge of some basic machine learning concepts, it will be much easier to explain the model and help the engineers to understand the output. From engineers' perspective, they think if researchers can improve their knowledge of SageMaker and the other machine learning services provided by AWS, for example, it will help improve their working efficiency, such as hyperparameters tuning, keep track of the model, and so on. But I think the point here is if there are already existed machine learning services, we should make full use of it, because a lot of things are already handled. So researchers don't need to manually or doing these things from scratch. And also, it will be great for researchers to have knowledge about unit tests, build frameworks, and have some basic understanding of code design principles. So in terms of the challenges when working with counterpartners, firstly, there are different levels of appreciation and experience with practices like unit testing, code reuse, code comments, and the like. And also engineers find it hard to understand the researcher's code in depth, such as how a feature is generated and what are the model's outputs, how things are done in a certain way, especially if the code isn't documented thoroughly. And another challenge is the build failures, memory issues, threading issues when the engineers deploy a model into a production environment. Those kind of issues slow down the deployment process. But one thing to keep in mind is those issues can due to the fact how a third-party machine learning library is working and implemented. So if people or team members have some knowledge about those third-party libraries, this will help solve some of those issues. And from researchers' perspective, they find it challenging to explain the technical machine learning concepts in a simple way. And they feel they are lacking of knowledge and experience in version control and the other software concepts, because as researchers, we we have different skill sets. And like I mentioned before, they are not synced with engineers' tasks. So those are the challenges or the things we can improve on. So with those challenges understood, let's see what are the current methods we have that people think are useful at Thomson Reuters C3 team. So firstly, people find knowledge sharing between researchers and engineers through meetings, blog posts, team chats, and the machine learning presentation series helpful. So the machine learning presentation series is a series of talk we started within our team to have each of our researchers volunteer to talk about any machine learning concepts. It can be simple as what is the train valid and test the data set up to what is a deep learning model. And those presentation series are open to all people, open to engineers, and we highly encourage engineers to join it because this helps engineers to understand more about the machine learning algorithms and the research challenges and so on. And also people appreciate the documentation such as blog posts about how to perform certain tasks. So for example, we have repository of blog posting like a step-by-step guidance of Git usage posted by our engineers. So this really helps engineers to make the most out of how to use version control and so on and use it in the correct way. And also we have the stand-up in our team when we're working on a machine learning project. We experimented different ways to have the stand-up. We tried like daily stand-up. We tried have the stand-up twice a week, but the goal is to see which frequency of those stand-ups are the best, and we don't take away people's time just to join the meetings. But this really helps our team members to synchronize and know what each other is doing, and this aligns us on joint efforts and priorities. The next one people find useful is having workshops involved with product team. I don't know for your project, but for our product, usually we have business partners, and there are some requirements from those product team. And having the workshops with product team to discuss the requirements, challenges, through within all of the roles, including engineers and the researchers, we find it helpful because sometimes engineers may have those ideas, researchers may have those ideas, but from engineers' perspective, they say they will see other challenges or risks. For example, the running time, the memory issue, and so on. And the next one we have is we have the bi-weekly spring review and the planning meetings. And we find this useful because this enables us to revisit and improve some of the working process. So every 2 weeks, engineers and the researchers sit together, talk about the good things about this spring, talk about what we can improve on for next spring. And the different ways of having the stand-up is kind of what comes out from those ritual perspective. And besides that, code walkthroughs prove to be very useful for obvious reasons. Finally, I have collected the suggestions people think that can further improve the working efficiency. So firstly, involve engineers with model training process. So as you can see, in the previous slide, currently the collaboration between engineers and the researchers at the research phase is almost 0%. But we figured if we have engineers in the model training process, this can help engineers to understand more of the full picture and help to enhance the code organization or reuse, and also set up some automation and testing during the model training will likely help mitigate some bugs and inefficiencies at the inference time. The next suggestion is researchers have more opportunities to learn software development techniques. So having some knowledge sharing sessions, not from the researchers, but from the engineer side, may be very helpful to help the researchers to understand more about best practices of writing production-ready code. And also researchers and engineers should start meeting frequently when a model is picked, even before the integration begins. So researchers do a lot of experiments, they try different features, different models, and before they send the model to the engineer for deployment, we'd like to have engineers to start interact with researchers. And so so in this way, the engineers can help researchers to do some running time performance profiling, so do some code review to identify bugs and identify potential risks such as the speeding issue, memory issue, so we can better estimate the time integration ETA. The next suggestion is we should have some channel or meetings where researchers and engineers can talk about the pain points and exchange what they learned. So this can be done in like Slack or Teams, whatever communication tools you're using. Because sometimes those issues there might be better ways for doing certain tasks that someone might not be aware of, but since it is not a huge pain, people don't ask about it. But if we have a channel of that, engineers and the researchers can share what they learned and the best practice of doing a certain task. The next suggestion we have is we should have a well-organized repository of information about how to do certain tasks. And those repositories should be easy to navigate and find information and should be kept up to date. So for example, if in NLP task, like we do a lot of text cleaning, or we use different ways to do tokenization. And if those repository of those different components are well documented and they are up to date, and it's easy for people to find it, this can avoid a lot of duplicate work, and also we can best make use of the code that people have already spent time and effort in it. And also, we should use common code design patterns when researchers learn those from the engineers. So this will help or minimize the code refactoring process when the model or when the inference code goes to the engineer side. And the next suggestion is we should have a closer pair programming between researchers and engineers. This helps engineers to understand algorithms faster, and that helps researchers to learn best practices of code design patterns or unit test, for example. And this also helps to identify those non-obvious bugs easier. So finally, we should always write clean and thorough code comment. So if researchers don't have time to explain the code, at least the engineers can read what does this or how this feature is generated and why we generate it in this way. So those are the summaries and the suggestions in terms of collaboration between machine learning engineers and the researchers from my team and my own experience. And I believe you have your suggestions and based on your experience. So, but I hope this is helpful, and I'm open to more suggestions and questions. Thank you.
Thank you so much, Luna. It was really an interesting presentation. So I start to collect some of the questions that we have in the chat. So I'll start those and then you can answer. So first of all, I'm going to with this question first because I believe a lot of smaller companies are trying to kind of fit their environment. So where would the role of data scientist fit in between ML engineer and researcher?
I think it really depends on the tasks you're doing. So if you are the only role in your team, you need to do both researchers and engineers. So I feel like there is no like a harsh line between the ML engineers and the researchers, because as I mentioned, engineers need to have technical knowledge about machine learning, and for researchers, it's better for researchers to have knowledge about code design patterns and so on. So I don't think there is like black and white lines between that. It really depends on what is your task and what is the goal. Are you focusing more on experimenting the data and building a model, or do you need to also build the model into the production environment? So if you need to build the model into production environment, you need to consider like thread safety. You need to consider how to automatically scaling up the computational clusters. Then I would say you are doing both research work and engineer work. Yeah, I hope I answered your question.
Okay, I'm reading this question that is still on the same kind of topic. So in the commercial world setting, who are researchers? Do you mean data science teams, or you literally refer to academic and research area?
Mm-hmm. So in our team, because we build machine learning models in production, so it's more practical researchers, not only focused on like writing research papers, but to understand the business needs and what the expectations from the end user's perspective. So the researcher here in my talk, I would say it's more practical researchers that we need to understand the way how to make a model into production. And also one thing that I think this researcher, I mean different than the academia one, is for academia researchers, we focus on getting the state-of-art results. We want to compare our results with the previous works. But in the practical application ones, so our researchers need to also consider, do we have, for example, do we have GPU access, and with this new model, so how long does it take to train? How long does it take to inference the results? So I think those are the difference.
Thank you so much for your answer. So still on the same topic, how formalized, well-defined are roles for engineers and research?
How formalized to define it? So I think it really based on the skill set and the work we do. Like I showed before, the skill set of engineers is more related to like code design and system design, API design, those best practices of like code design principles, how to modulized the code, make it efficient, and also write unit tests and make sure that the build is successful, and trying to think about the edge cases and how to make the model ensure the high availability of the models. As well, in terms for researchers, I think the skill set and the task are different. Like researchers, we usually do experiments in like Jupyter Notebook or SageMaker Notebook. We try different ways to formulate the data or create features from it, or try different models. And eventually we just pick one model that fits most into the current situation, like it gets a good performance among all the models we tried, and it also meets the requirements from the end user. So those are the things researchers consider. So as you can see, researchers focus more on the experiments and the output from a model, while the engineers consider more about how to make sure the model is working properly and available all the time when it was used or put in front of an end user.
Thank you so much, Luna. So now we have more, still an interesting question. So in your opinion, what would be an optimal engineer research staffing ratio?
That's a good question. What's the optimal ratio? So for now, we are, based on my experience, I think 1-to-1 may be the perfect, because in a project or in a product, it can be divided into different components, right? And each researcher may be responsible for one of the components. So for example, this component is about entity extraction, another component is about classification. So it would be great if for each of the researcher, we can pair it with one engineer. So we can have closer pair programming and closer relationships of understand the work on each of the sites. But obviously it depends on the resource from your team, and also how a product is modularized into different models.
Thank you. Good answer. So the next is about some of the suggestions you provide. You suggest that engineers and research can attend Scrum together. Can you elaborate on this?
Sorry, Scrum together?
Yeah,
Scrum means Scrum meetings?
Yeah.
Yes. So currently what we are doing is we have a spring review bi-weekly. And in this spring review, we have engineers and the researchers all sit together. And the researchers will talk about their plans for next sprint. And I can see that I understand that it's harder for researchers to follow the Scrum pattern, because there are a lot of uncertainties. But having the researchers sitting together with engineers help engineers to understand the research challenges and kind of understand what are the plans the researcher is going to do for the next 2 weeks. And they will also understand what are the risks along the way. Maybe this model doesn't work, but we probably need to try this model. And have researchers join those meetings with engineers. We understand engineers are, for example, setting up some framework for the text processing, or they are working on some data lake pipelines. So those help researchers to understand what engineers are doing and how what engineers, the task engineers do can potentially help, or the researchers can use it in the future. And for the daily stand-ups, we have 3 different kinds. The first one I mentioned is having the stand-up including all the engineers and the researchers. And those stand-up, for now, we have once a week. So we will sync with all the 2 roles and have understand or be on the same page. But we also have those daily stand-ups within engineers and the stand-ups within researchers separately. So maybe in those separated stand-ups, we will talk more about the technical details. So this is the way how we are currently performing.
Cool. Let us know if Luna answered completely the question. Thanks. So now we have a question, and that immediately include a follow-up question. So I'll read first the first part of the question. So when should the researcher yield the floor to the engineer? And when should the engineers yield the floor to the researcher?
So I think from what we get based on our experience, it's the earlier the collaboration starts, the better, or it will make it easier for the future work, right? Like I said, once a model is picked, we'd like to have those collaborations start. And this will really helps to both roles learn from each other. And so say, for example, we pick the model from a researcher, and then we want to explain how the model is trained and how those features are generated during the training process. The engineers understand. And then when the engineer need to deploy the model to the production environment, they usually just deploy the inference part. But also this involves adding those features, extract the features from the data we need to predict. So if those collaborations start earlier, and when the engineers deploy the inference part, it will be much easier. Sorry, did I answer your question?
I feel you also answered the second question, but Sybil, if you can let us know in the chat if this covers both of your questions, it would be great. Thanks. So we are moving to the next one. So this is a personal question, kind of. In your own professional experience, which career path do you prefer, engineers or researcher?
That's a good question, because I've been thinking about this as well, and that's also the reason why I did software engineer as well as the research scientist. And the more I do it, I feel like, firstly, both of the roles are very valuable. The work they do, if we miss one of the roles, I don't think a machine learning project can be called a success project, because we consider different points from different roles, right? So for personally, I think I like doing all the experiment or trying to create some models that can solve some problems. That's why currently I'm doing more research works and applying the state of art and trying to put them into production and see what are the issues that can be associated with a model in terms of like the speeding and so on. But at the same time, I'm still very interested in this engineering work. That's why within our team, we learn from each other, and still during the process as a researcher, I learn a lot of engineers' best practices. So I would say if I want to move forward for my career, I want to be a researcher, but with a very solid software engineer skills. Thanks.
Thank you so much. That was a great answer. So I'm gonna follow up the previous question. So the one when researcher and engineer should start to collaborate. So what are the key moments in the journey when that shifting of who is leading has the best chance of improving outcome? This is more about pain point in the journey where it is important to listen to one or the other. Does it make sense as a question?
So you want to know what is the moments that that why we need to shift that part, shift the collaboration as early as possible?
Okay, so she's asked me, he is asking me to read also this part. Maybe there is a point where it is good to check in with the engineer whether the insight from the researcher is possible to implement, or maybe there's a point where the researcher to learn that what they are building may have problematic impact.
Yeah, so I think this really goes down to transparency of the work on each of the role. I really don't like to say two of those roles because we're actually like working together. So I will use the word we. But what we notice is, so for example, if there is no collaboration at the research phase, researchers has finished the one model and the researchers give it to the engineers and the engineers do the deployment. And the one thing we need to keep in mind is when we do this deployment and the integration process, we usually will give an estimated time for the other team. For example, for the product team or for other teams who are waiting for our output. So if the engineers get this model from the researcher without any pre-knowledge about how the model is trained, they may have a wrong estimation of the integration time. They think, oh, maybe this is like only take 1 or 2 weeks, but when they take over the model, there are problems coming out, right? And the reason is, first, they don't know how the model is under the ground, the in-depth how the model is implemented, and what are the expected output. They don't know that because they refactor the code and they are testing the output from each of the component in the model. If they don't know that, this can slow down the process. And then there are some other risks like, does this model rely on some third-party libraries? If it does, then there may be some other issues coming out. So those are the pain points, or that is the moment that we realize it will be really important. The engineers start to understand the model earlier, not just until right before the integration, because this may give us more risk and it will probably delay the time we can really hand over or integrate the model into the environment.
Thank you so much. I hope this answers Sybil. Sorry. So we have another question. In one of the slides, you talked about working with the counterpart for code review unit tests. So how involved is one team with the other? Do engineers get involved with unit testing the research code? If yes, so which team generally leads such exercise?
In terms of the unit test?
Yeah,
okay.
They're talking about the unit tests and code reviews.
So code reviews are definitely the #1 helpful things to have both of the roles on the same page. And also this helps the engineers to refactor the code and understand the output. In terms of the unit test, for machine learning researchers code, it's a little bit tricky because we don't really know what's the output from data, right? So we cannot really call it, I think we cannot really call it a unit test, but basically we're checking some very simple things engineers are waiting for the researchers to to find out some obvious issues. So for now, the unit tests are prepared by our engineers according to their expertise after they understand what should be returned by the model. But deep to the model, there are still other testing researchers need to consider.
Awesome. Thank you so much. So we do have one last question, but I don't feel it's very relevant. So I'm going to ask you first if you're familiar with the analytics translator role.
Sorry, no.
Yeah, I never heard before. Apparently, there is an HBR article that talks about this, but seeing that it's kind of not relevant to this one and we are not familiar. So I think we are good. So if no one has any other question, we can close this session here.
Okay.
Okay.
Thank you very much.
Thank you so much, Luna. It was so an interesting presentation, and I hope to see you soon and again to our conference.
Thank you, Nadia, and thank you all. Bye.
Thank you, everyone.